Okay. Can I start? Okay. Can you hear me from home? Okay. Good morning, everyone. Thank you for being here. And we can start with the first session of the tutorial about RawGraph. Can I put on more? Okay. Okay. So, just a moment. Okay. My name is Maria Celeste, and this is our team. I'm from Italy. I'm currently attending the last year of my master degree in communication design at Politecnico Milan. And today I'm here to give you an introduction about RawGraph 1.0. And my colleague Camilla will explain you the practical part of the tutorial. And other guys here are here to assist you. So the presentation can be reached from this URL, and I try to, you should have the link, I think so, okay. Maybe we could put in chat.
I can do it.
Okay. So what we'll see today is RawGraph 1.0, the tool, example, and case studies, a couple of things that you need to know, such as how to organize the dataset, some visual model, and then we'll do some guided exploration on RawGraph on some kind of visualization like Dendrogram, circular and linear, used to represent hierarchies and proportion, and B-swarm plot for distribution, time series, and proportions, then that my colleagues will do in a while. RawGraph can be reached through a website, and the website is this one, so rawgraph.io, and it is a free website and open application for producing data visualization. Just before describing the tool, I'd like to show you that we have different URL. So the first one is for the project website, and you can find different information like learning section, tutorial, blog, and other important things to know before to use the tool. The second one, this one, is the public version of the app, which is the most stable one. The third one is the development version that review series of new feature, and to use it you need to use this username and this password. And the last one is an experimental version. RawGraph is an open source web tool developed by Density Design Lab, Imaging and Calibro, three realities around Milan. We use this payoff to describe RawGraph's intent. So the link between spreadsheet and data visualization, because with this payoff we stress out the fact that the tool is designed to be very easy and quick to use. Out on internet, there are already a lot of valuable data visualization applications designed for a general audience. But the difference with RawGraph is that RawGraph is fully free and open source, has an easy-to-use interface that we are going to show you. And RawGraph facilitated design-oriented approaches to data visualization. So, in fact, we use RawGraph when regular graphs are unable to show the complexity of data. And finally, as we said, RawGraph is based on approach design-oriented, and with this we specifically mean the fact that sometimes we need to manually intervene on the visualization that we produce with the tool to make them more adherent to a specific requirement of our data or communication context. More specifically, with this design-oriented, we mean this example, which is a model based on a narrow chart, but that has been significantly manipulated in order to fit a newspaper page and to communicate it better specific data. This is an example that most searched pages on Wikipedia and is divided by categories. So each row is a category and each category has a different color. As you can see, we have different peaks according to what's happening here during the year. This is another example in this visualization based on a divided and re-elaborated tree map where we have some square, and every square corresponds to a different country and is displayed on the globe to resemble the original geographical position. So when we want to use RawGraph, we usually have to follow 5 or 6 steps. So you firstly have to grab a dataset. You insert it into RawGraph, for instance, using a copy-paste, as we seen later, or by some dataset that already exists on the tool. And then you can start exploring your data through that visualization models by mapping the data dimension on the so-called visual variables that are mapping function that are exposed on visual model. Once you reach the result that satisfies you, you can export your chart in a different format, and then optionally, as we said, the 0.6 you can edit it in software as Illustrator or Figma. It is necessary to select and organize a dataset. In fact, as we see here, there are different ways to organize the dataset, and they depend on what we need. There is a difference between the two structure, matrix and list. According to the visualization we want to use and the chart that we need, every chart supports a specific structure. RawGraph usually prefer matrix because more model works better with matrix, but it's important even list. So the difference between matrix and list is that matrix is a data structure in which all variables are on the top. So here we can see the violet one, and item are on the left. Instead, list is a structure where for each variable of interest there is a row. So each item recurring, for example, here H&M for 2 row, Zara 2 row, etc. And variable is vertically. Instead, matrix are horizontally. There is a feature that allows you to switch from one structure to another one. This is the stack function, and here there is the tool to use this function that we'll see later in the tutorial part. So, okay, just a moment, sorry. Okay. As we said, is important that on RawGraph is necessary insert only the dataset we really need. So we have to filter it with parameters that answer our question. So this is the complete dataset that we have filtered, and here we have just 3 columns. So with just 3 columns, so the overall purpose of the research is therefore to find an answer to a research question. And with just these 3 columns, we obtain this chart. So this is an example of visual model that you can create on RawGraph. It's called Voronoi, a model that can be already used in its definitive version. So it's a model that creates the minimum area around each point defined by 2 variables. And important things so is that, as we said, with less value, with filtered data, we could obtain this kind of structure. So after having insert our dataset in the form of a matrix or a list, so it depends what we need, or having chosen one of the preset dataset already available on RawGraph, it is necessary to select visual model. But we ask which kind of visual model. So it depends by what we would visualize, and what we need to represent with our chart. On RawGraph, we could filter here the chart on the top right, as we can see in this GIF, and choose our visual model. So there are main family of visual models. So hierarchical, relational, temporal, and statistical distribution. Special models like map are not experimented yet in RawGraph. And now we'll see a little bit of this visual model that we need to know for create a correct visualization and a correct chart. So the first one is the hierarchical models. So hierarchical system ordered sets where elements are organized in a given relationship. Hierarchical models, some example of hierarchical models could be Dendrogram, as we see later, and tree map. And all of them, so like the name says, are useful to show hierarchies among different elements. So we could, if we filter, we can find other model for representing hierarchies, like circle packing, or 2 different kind of dendrogram, Sankey diagram, or tree map. This is a model that called Dendrogram that we'll do later in the tutorial. Dendrogram here analyze branches of the animal kingdom in this specific kind of dendrogram is called linear dendrogram. This is a model that display hierarchically structured data with tree structure, where the nodes are represented with these dots, and the hierarchies in this case is represented vertically. And this is all the categories that we split in all different kind of nodes. So this is another model called tree map, which displays hierarchical structured data and related quantitative dimension. It is composed of area. This is an area divided into small rectangles. So each area has its own rectangles, representing the last level of tree structure, and the rectangle size depends on the quantitative dimension. So this is another model for representing hierarchy called circle pecking. Circle pecking displays values of leaf nodes of hierarchical structure, but this hierarchical structure is different from the structure that we see before, because this is a chart that uses circle areas. We could represent another quantitative dimension with sides, so the sides of the dots and bubble, or qualitative characteristic with colors. So we have different class, so different categories as we see here. Now we see another visual model, so relational model, like is networks. Networks are relational models. Certainly they are not the same networks that we could make with, for example, Kefi or another tool, but we could see at the same time that we have two different kinds of chart for representing network. The first one, so here we could filter again, and this is the two model, the two chart, the arc diagram and the Sankey diagram, and now we'll see what they are. So this is an arc diagram. Arc diagram allows us seeing relationship among nodes. So these are the nodes as we seen on the previous chart. The nodes could be displayed in a different order. So here we have nodes ordered by minimizing arcs overlapping, and here nodes ordered by name. So the relationship between these nodes are representing by this arc, so this line that could connect the node. Another model that represents networks are this one, the Sankey diagram. The Sankey diagram represents flow among nodes of a network. Here the nodes are representing in a different way from the previous chart, because there are not dots, but there are these rectangles. So all these rectangles are our nodes, and 8 of these rectangles represent their value. On RawGraph, there are two, we could say, similar chart, but the truth is that they are not similar, because we could confuse the Sankey diagram, so this one, with the alluvial diagram, this one. It could be seem very, very similar, but there are two main differences. So the first one is the alluvial, so this one. First of all, is not used to represent a network. It is used to represent a correlation between elements. Moreover, alluvial, so this kind chart, is made to split elements. So here, for example, to understand better, we have, so this is a visualization that represents hate crime in New York City. Here we have gender node on the left. In this case, we can see male node and female node, split both by race split by age group, and finally on the right split all these nodes by bias motivation in order to study hate crime, so in New York City. But instead, as we said so here we could not skip this step. So every node is here and here and here. In Sankey one, in the Sankey diagram, instead we could skip the steps. So we could pass from these nodes to, for example, another one here or here. Okay. Another important family are time series. So time series is there are a lot of different charts of RawGraph to show time series, because time series show development of some phenomena over the time. And as we see here, there are a lot of charts that could represent this intention. If we filter, we can see some chart like this one plot that we'll see later, or BAM chart or another one. So, for example, here we have chart called line chart that show a quantitative dimension over time period. The time period is indicated here on the x-axis. Each line, so we have a lot of line, and each line represents a category. The category are shown here. Each color is a country, so we could find a color here that corresponds each one to a category here and a line here. So each line represents a category, and in this example, in this specific kind of line chart, we can see the development of foreign residents in Milan over the year. Each line with a different color represents the growth of a population. So color can be optionally used to encode additional quantitative or categorical dimension. There is an important and useful feature on RawGraph. so this one, that we can use to split the different categories that we have seen in the same chart here. So here in the same chart there are all the category together, and instead here all these categories are split in different charts. So this function on RawGraph is called small multiples, and it's a very useful function to analyze better, for example, the difference between each line, each category, and to make a better comparison with each one of them. With the same data set, so always with foreign residents in Milan, we could make another kind of chart, so the BAM chart. This is a dataset that we use, already available on RawGraph. We can make this chart. That is a chart that allows the comparison of multiple categories, similar to line chart, over a continuous dimension and evolution of its sorting. So here we could see an evolution, and the BAM chart is useful to analyze among all the category which one has the highest value in a specific point. For example, we could see a specific highest point, and we could see that one different from the line chart and BAM chart is that, for example, here we could see the sum of all these values. So we have the total value, and it's represented by the high of the stream. Here at the sum of the value, and we don't have we don't see the sum of the value in a line chart. So it's similar chart, but it could be used for different intended. So the last family is the statistical distribution one, necessary to display the frequency of a phenomena. Filtering by statistic. Here, okay. Filtering by statistic, we can find chart like this one we could see here. And for example, there is here an example of this statistical distribution. This is a chart called scatter plot. So the scatter plot is the most famous we could see and used once. And in this example, we can see a statistical distribution plotting two dimensions to analyze, as we can see here, highest grossing movie in history. On the x-axis, there are the budget of the movie. Instead of the y-axis, the worldwide box office. So crossing data, we have a lot of this kind of bubble of dots. Each one indicates a movie and highest crossing movie. Important in this scatter plot is already the size of this dot, as we have seen in other chart too, because with size and dimension we could represent some quantitative categories and dimension, and with even we could add some color to distinguishing better the movie in this case. So Here we have another two example. The first one is the hexagonal binning, and on right we have the contour plot to use both to visualize the density of point. There are very simple to make this chart on RawGraph, and they are very useful because allow us to have an overall view in a different way of different kind of phenomena. So I hope that I've been clear. And now I leave you with my colleagues Camilla. Will show you step by step more detail how RawGraph works with guided activity.
Okay, good afternoon. Now it's time to play with RawGraphs. So we will see together a couple of models that we can explore. And I will try to explain all the steps, but if you have any doubt, feel free to stop me and interrupt me. So what we will see together is basically a model which is called Dendrogram, and it focuses mostly on hierarchies, as my colleague said before. We will see it both in a linear way and in a circular one. Later, we will see together to show distributions and proportions the Voronoi plot. So let's start. Hierarchies and proportion. We will see how to reach this result, which, as you can see, focuses on hierarchies. We have all the steps. This is really similar to what was seen before as an example, but it's oriented horizontally. So this is also a function that is useful for you because it depends on what you want to get and where you want to put the visualization at the end of the project. So in this case, for a slide, it's better to have an horizontal view. And then we have also this visualization here, which is the same, but in a circular way. Also, in this case, the meaning of the visualization and the dataset is exactly the same, but the final form and shape is completely different. So here are the steps that we will follow to reach the visualization. We will get to RawGraph, and then we will use this data sample, and I will show you where it is. And then the third step is to choose the visual model that we want to develop. And then we will map the data variables and play with the features. And in the end, we will export the visualization. So let's reach RawGraph in here. This is the home page. As you can see, it's really intuitive, and you can click on Use It Now to start. And our first step is a really important one because, as my colleague explained before, everything starts with the dataset. So we may have an idea of what we want to reach, and in this way we will select and insert on RawGraph data that perfectly suit our final visualization. RawGraph offers us many ways to insert data on a website. For example, we can paste our data. In this case, we will click on here on the left side, and we will reach, for example, a simple spreadsheet. We will select all the data that we need. In this case, as you can see, we just have 3 columns and they're enough. We can see common B on RawGraph in here. So we click, and then with command B, we insert data. As you can see, we've inserted the same data that we had on the spreadsheet here on RawGraph, and it's really fast to do it. But there are many other ways to insert data. It depends on what is the data set that you have at the beginning. So I will show you all, so you will be able to choose the one that best fits your needs. We can also upload our data by browsing on our computer. This one. So we've inserted this way the same data set by browsing our computer. But also, I would like to show you how to put the data on RawGraphs basing on an URL. So if we have the spreadsheet, for example, we will start from here. And here we need to remember that in order to RawGraph being able to select the data, we need to publish our document. And in order to do that, we can say File, and then Share, Publish on Web. When we're here, be careful to select not web page, but CSV, okay? And then we can just easily copy our URL. Then we get back on RawGraph in here, and we will select from URL. Here we paste our URL, and we have the same dataset. What we're going to work on today in order to explain our models is another function that is really useful also to try and see what happens with RawGraph. So there are many examples that are already available on RawGraph, and you just need to go to try our data samples. As you can see, there are many examples, and I will also show a super useful function, which is a function that Maria Celeste before told us. For example, I select this one, which is a matrix dataset. We can recognize it because it's wide, and there are more than 3 columns, and items are not repeated basing on variables. So let's say that we have this matrix in here, and we need to get a list. RawGraph has this function now that is really useful, which is stack on here on the left. And we can decide on which column we want to base our list of data. So if we click in here, stack on column, and we can select category, we will have category as first column, and the other columns will be displayed basing on the first column. If we want to change it, we just go on type, and everything changes. What's interesting is that sometimes this can be useful to start even to change our data set in a simple and fast way. But let's get back to Dendrogram. So we reset in here to our data samples, and we will find a dataset example that fits the Dendrogram. In order to understand which dataset available is better to be used with Dendrograms, we should go and have a look at the subtitles of these boxes. So, for example, in here you can see that this is the classification that we need, and the Dendrogram is on the subtitle. So we can click and select this one. In order to create an easy model, we should have a look at the dataset to know what we're gonna create. So here we have different columns, the family, the subfamily, the genus, the subspecies. Also, naming the columns in an intuitive way can help us later to create the graph. Then we have the names and a value, which is the risk of extinction. So now that we have all this, we can scroll down. We can also filter the charts in order to see better what we need. So here we go in show, and we are looking for hierarchies. As Celeste before showed us, there are many ways to show hierarchies. One is circle packing that can be useful to have a wide overview of our dataset. Tree map is really famous, but in this case we were going to select linear dendrogram. We select our model, and then we go down in here. We should have a look and be careful, because where there is a red asterisk, it means that category is mandatory. So we need to put at least an item in here in order to create a graph. Saying that we are creating a hierarchical model, we will need a hierarchy, and the order in which we put the data is also important. So we will put the family, the subfamily, the genus, and the subspecies. As you can see, if we scroll down a little bit, we already have a graph, and this is already useful and ready to be used. But we can do a little bit more, because we don't want to just see hierarchies, but we want to see proportions. Specifically, we would like to enhance the risk of extinction. And there are two ways in which we can do it. we can take the risk of extinction and drag it in here on the size and also on the color. We will notice that our graph already changed a lot, and this visually really helps to get a fast and easy way to notice that some dots are bigger and darker than others. We will add the names on the label in here in order to see which dot corresponds to which name. Okay, so let's say that our graph is almost ready, but there are a few last steps that we can use in order to make a graph more suitable and nearer to what we need. So first of all, we can modify the dimension. So the width, for example, can be enlarged a little bit, and we can reach, for example, too much. Let's say, okay. Okay, so now it's really easier to read, but there is something more that we can do. We can add a little, okay. This way we have enlarged the space between the dots, and so it's easier to read. But it's really customizable, because if we want to, for example, to get a maximum diameter of the dots higher, we can just get an higher value here, and instead of 20 we can say, for example, 28. Other things that we can do is that we can change the color already from RawGraph. So here we have a color scheme based on blue. Two others are available, red and green, but if we want, we can also just click on here and paste the code of the color that we need, or in case we just click on another and everything changes. In this case, the labels are already readable and clear, but I inform you also that it's possible to add an outline in case that maybe we have a different background, or maybe some texts are overlapping, so we can use this. When we are done and we're happy with the result, maybe we can also modify this a little. Okay. When we're happy with the result, we just need to go down here on the last part, and now it's called this, but already from RawGraph we can change the name, and let's say example. And we can decide in which format we want to export our graph. SVG can be a good choice, for example. And another thing that could be useful is that after that we've downloaded the file, we can also decide to open with Illustrator or even PowerPoint if you don't have Illustrator, in order to modify some elements. Okay, now we have seen the linear dendrogram, and we will see the same thing with the circular dendrogram. Circular dendrogram works exactly the same, so we will just repeat the steps that we've done until here in order to get the same result. So we put name on the label, the risk of extinction on size, and color. It's not mandatory to put the risk of extinction both in size and color. It just makes everything a little bit clearer, but we can decide. Our graph is ready. We can make a little adjustment in here. For example, as you can see, this text is cut at the top. So we go to the margin top and we can augment this value in here. Okay, instead of 10, I put 60. Yeah. So this way, everything is visible and we are ready. As you can see, there are little parts in here where the text reaches the dots, and in this case, maybe it can be hard to read the text. So could be useful to add the labels and to show the outline. In this way, as you can see, there we have a white outline out of the text, and nothing will overlap, and we will read everything clear. Okay, also in this case, we can export as we've done before, and obviously manage to open it in another program. Any doubts about this? Okay, then I will go on with the other visualization. Okay. Next, distribution, time series, and proportions. This visual model that we'll see now is really useful and easy to build, and also it's kind of useful because it allows us to create a complexity of data in one visual model. So this is what we're gonna get together. As you can see, we have many categories divided in groups and enhanced by the color of each category. Density of dots will help us to read the data set and to understand where there is a higher concentration of elements. Actually, the steps that we're going to follow are almost the same as before, so I'm not going to read them again, and we will reach directly. Yeah. Okay, we're back on RawGraph, and here we reset and we try another data sample. We are looking for the B-swarm plot. In this case, we are going to use a data set which is called New York mean wage per occupation. We click in here and we will see that we have 3 columns. In this case, the first column concentrates on the specific occupation, for example, management, general and operation managers, so on, the mean wage of that occupation, and the category which it belongs. Down in here, we're going to select the B-swarm plot. Then we go down again and we reach the third part, the mapping. Red asterisk, which means this is mandatory, and the x-axis is what we're gonna see horizontally. So in this case, what we're interested in showing is the mean wage. But also, we want to show the mean wage on the sides too. And what we're interested in dividing is the category. So as you can see now, at the moment, we just have one huge group here down, but we want to divide it as we said in the previous example. So we're going to put the category in a groups and also in a colors. Here the colors are really helpful to distinguish the different categories. And we can also change the palette down in here in colors. There are 2 palettes that are useful to be used when we have many categories and elements. In this case, we can decide, for example, to use the turbo discrete or the spectral discrete. I will select this one. And our graph is already readable, but we have a problem on the left part. Same as before, we can get a higher margin left. So we're going to change this value. And in this case, as you can see, we have fixed the problem and now everything is readable. In this kind of graph, something can be useful. Since it concentrates on the density of dots, but it does not overlap the dots, it's better to have a wider visualization, so a larger one than a narrow. So we're going to get a higher width. Maybe we can say, okay, as you can see now, it's more readable and dots have more space to display. What we will notice in this one is that the dots and the x value are linearly corresponding. So what happens is that a higher value on the x-axis corresponds to a bigger dot in the graph. So we will notice that, for example, this category in here, which is healthcare, has a mean wage which is the highest of the whole categories. But there is a huge concentration in here, production, around this value of the wage where dots really are dense. Also in this case, we can show a legend. And in order to do this, we just go to the legend in here and we say show legend, yes. So on the right, we will see the legend. Obviously, we can adjust the margins, but it's going to help us to read what's on the other side. And also, if we want, we can show the labels. But in order to do that, we need to insert the label in a third part. So we take the occupation, we put there in on the labels. As you can see, we have so much data here, and in this case, when we have this kind of overlapping and we don't know what to do, we just flag auto hide labels, which really help to select different labels and to make everything easier to understand. Also, this is a case where the outline helps us and we just flag it. Okay. If we like the labels, we can keep them. If we don't want it, we can just change it and get back to where we wanted before. Okay, so this is our graph. We can export it. Example graph. Example 2. SVG and download. Okay, so basically we have seen together also the bee swarm together with the Dendrogram, sorry. Here are useful links and resources that you can reach if interested. Any questions here or offline, online? Okay, now it's your turn. Abbiamo ancora tempo? Okay. Now it's your turn. Let's say that you can try. We have prepared this part that I'm happy that we have time. There is a question? Okay.
Yes.
We have two. One
Okay.
from Eduardo. Yeah.
Okay, interesting question. So we will see together. Is it the same on the chat?
No, it's two different persons.
Okay. So let's hear one.
Yeah. Eduardo, you can go ahead.
Yeah, I'm just having, I just don't know how to interpret the changes in when you are representing networks. So what does the link change when you have, for instance, in the, I think it was on the Sankey diagram?
Okay.
When it blocks changes to A, to C, to D, then what is the interpretation of the connection of the link between the nodes? Because as far as I understand, A, B, and C are nodes, but then their connections are different.
Is it this about the Sankey diagram, right? Hear it out?
Yeah.
I will try to answer you, and then if it's not clear, you can feel free to ask me again. Here, the Sankey diagram focuses on a network perspective. So it means that we have all the values, which are these lines on the left, as you can see. But what happens is that all the distributions of these elements does not have to follow a step, has in the other. So here, all the elements need to pass through another step and another step and another step. So the value at the end, like in the right part, in the last part, is the same value as the first, but redistributed. Instead, in the Sankey diagram, it can happen that here, for example, the nuclear value can distribute and reach, itself in a thermal generation. And instead, this one reaches the bioconversions together with the UK land-based bioenergy. So this value in here, the bioconversion, it's split between these values here has input values. This kind of diagram is useful in order to see the complexity of different values that intersect themselves and create groups and subgroups. Any other? Is it clear or?
Okay, yeah, I think I got it. It's like a representation of a network inside out. So instead of looking at nodes connecting, you're looking at links leading to nodes. Okay.
Yeah, exactly. This one is one of those visual models that if you try to insert data gets more clear. So with a try, it gets better. So the other question was, when do you save as RawGraph? This is another interesting question that we will see now together. Okay, let's say that we are here in RawGraph and we have reached this part. We have done quite a long work deciding what parts putting where, and we have reached a good result, but we don't want to save it now as an SVG. We would like to start again later. In this case, it's useful because we can save the file here as a RawGraph file, and we can download it. Then we get back at the beginning, and we can open our project. Vediamo dove.
To save the features.
Okay, as you can see, I hope you saw it, in case we can do it again. We have recharged the same file on RawGraph, and this means that we can start back where we left our project, and we don't need to restart everything from scratch. Clear in the chat? Fantastic, thanks. Okay. So let's get back to our presentation. Obviously, if you have any other questions, feel free to ask us. And it's time to make a little try. You can choose whatever you want to represent. You can decide to use our data samples that we've seen together. You can try with others. Also, if you have your own data set and you would like to see what can happen with the RawGraph, you can do it. And we have prepared this slide on the presentation. I remind you that the link to the presentation is in the chat. So you can reach this slide, and when you have exported a visual representation that you like, you can paste it in here, and we can maybe duplicate or just add one to the other. Because at the end of the time of the presentation, we will check them together, and if time is enough, we will talk about them. So you can try, and we wait for your result. If there is any problem, we can reach you to your computers.